My dear students and parents, by God's grace, my educational videos are available in YouTube to 10th Cbse, plus 1 Cbse, plus 2 Cbse, NEET and IIT students in the subjects Maths, Physics, Chemistry, Zoology and Botany in English language. We have already discussed how to derive the formula to find the potential at a point due to a point charge. In this video, we are going to derive the formula for the potential, that is electric potential at a point due to dipole. Electric potential at a point due to an electric dipole. First of all, we have to take an electric dipole. Here, the electric dipole AB is taken. At point A, the minus Q charge is placed, and at point B, the plus Q charge is placed. What is electric dipole? We have already seen in our previous videos, that is two equal and opposite charges separated by a small distance constitute an electric dipole. Two equal and opposite charges. At point A, we have taken Q charge. At the point B, we have also taken Q charge. So both charges are equal, but at the same time, both the charges should be opposite, so that at point A, we have taken minus Q charge, and at point B, we have taken plus Q charge. So two equal and opposite charges have been taken. They are separated by a small distance. The small distance between the dipole is 2D. The center of the dipole is O. So that the distance between the center of the dipole and the minus Q charge is D, and the distance between the center of the dipole O and the plus Q charge is also D. We are taking a point P at a distance of small r from the center of the dipole. R1 is the distance between the charge plus Q and the point P. The R2 is the distance between the minus Q charge and the point P. So now we have to calculate the electric potential at this point P due to this dipole AB. How can we derive the formula to find the electric potential? Let us see. We know that the formula for the potential at a point P due to the charge plus Q equal to 1 by 4 pi epsilon naught Q by R1. What is the general formula? The electric potential at a point due to the point charge is 1 by 4 pi epsilon naught Q by R. The distance between plus Q charge and the point P is given as R1, so that we have written in the denominator R1. So this is the potential at the point due to the plus Q charge. The minus Q charge will also produce the potential at the point P. So we have to write the electric potential at the point P due to the minus Q charge. So the potential at P due to the minus Q charge equal to 1 by 4 pi epsilon naught minus Q by R2. Why we have written as R2? Because the distance between the minus Q charge and the point P is R2. In this diagram, the distance between the center of the dipole and the point P is given as R, but the distance between the plus Q charge and P is not given. If two sides are known in a right angled triangle, we can find the value of the third side on applying the Pythagoras theorem. That is, hypotenuse square equal to opposite side square plus adjacent side square. Similarly, if we know the value of one side and one angle, we can find the other sides by applying the trigonometrical ratio in the case of the right angled triangle. In the case of the standard triangle, if we want to find the distance between plus Q and the point P, we need the measurements of two sides and the angle between those two sides. So here the angle between the two sides, that is R and D, is supplied as theta. The distance between center of the dipole and the point P is given as small r, and the distance between center of the dipole and the charge plus Q or minus Q is given as small d. We have to find the total potential at the point P, because the plus Q charge will produce the positive potential and the negative charge will produce the negative potential at the point P. So the total potential at the point P due to the dipole is V equal to 1 by 4 pi epsilon naught Q by R1 minus 1 by 4 pi epsilon naught Q by R2. This is as per the superposition principle. That is, the total potential due to the dipole at a point is the sum of the potentials due to the charges plus Q and minus Q. So that we have written the formula for the total potential as capital V equal to 1 by 4 pi epsilon naught Q by R1 minus 1 by 4 pi epsilon naught Q by R2. If we take the common factors outside, we will get V equal to Q by 4 pi epsilon naught 1 by R1 minus 1 by R2. In this case, we have to find the distance R1 and R2. If we do not know the distances R1 and R2, we cannot find the derivation for the electric potential at a point due to the electric dipole. As I already told, in order to find the distance R1, we need two distances and the angle between those two distances. We can find the distance R1, that is plus Q charge, and the point P on applying the cosine law. What is cosine law? The cosine law is a square equal to b square plus c square minus 2bc cos a. If we consider a standard triangle ABC, there are three sides. One side is A, another side is B, the third side is C. We are getting two triangles, that is BDC and ADC. So first we are taking the right side right angled triangle BDC. In this right angled triangle BC represents the hypotenuse. So we know that as per the Pythagoras theorem, the hypotenuse square equal to opposite side square plus adjacent side square. So the hypotenuse square is written as BC square, that is equal to the opposite side square. What is the opposite side square? The opposite side square is CD square plus the adjacent side square. What is the adjacent side square? The adjacent side square is BD square. Now we have got the BC square in respect of CD square plus BD square. But we don't want BC square in respect of CD square and BD square, but we want the side BC square in respect of AC square and AB square. That is, we are going to express the side small a relating the sides B and C. Then we can write CD square as AC square minus AD square. How can we write CD square as AC square minus AD square? If we consider the left side right angled triangle ADC, the CD represents the opposite side because theta is here. CD represents the opposite side. So as per the Pythagoras theorem, the opposite side square equal to hypotenuse square minus adjacent side square. Here in the case of the left side right angle triangle, what is the hypotenuse? The hypotenuse is AC. So the hypotenuse square is AC square minus adjacent side square, that is AD square. On seeing the diagram, we know that BD equal to AB minus AD. We have to write BD as AB minus AD because we have to represent the side C. We have already got the side B. Now we have to get the side C, so that we are going to represent the BD as AB minus AD. Then BD square equal to AB minus AD the whole square. On seeing this AB minus AD the whole square expression, we understand that it is in the form of A minus B the whole square. What is the formula for A minus B the whole square? A minus B the whole square equal to A square plus B square minus 2AB. Here in the place of A there is AB, in the place of B there is AD, hence AB minus AD the whole square equal to AB square plus AD square minus 2AB into AD. Now we have got the C square. The AB square is the C square. So already we have got the B square. Now we have got the C square. This AB is also C. Next our duty is to find only B. It is written again BC square equal to CD square plus BD square. So that I have given the arrow mark here. So we have already determined CD square as AC square minus AD square. So can we substitute AC square minus AD square in the place of CD square? Yes, we can substitute. If we substitute CD square that we have already determined, we will get AC square minus AD square. Then if we substitute BD square, we will get AB square plus AD square minus 2AB into AD. This is also we have already determined. So now we have substituted CD square and BD square. Thereby we are getting the equation BC square equal to AC square minus AD square, AB square plus AD square minus 2AB into AD. This minus AD square and plus AD square can be cancelled. Thus we are getting BC square equal to AC square plus AB square minus 2AB into AC cos theta. How we have written AD as AC cos theta? We know that cos theta equal to adjacent side by hypotenuse. Therefore, adjacent side equal to hypotenuse into cos theta. In this case, the hypotenuse is AC. So, we can write the adjacent side AD as AC into cos A, because the angle between these two sides is A, so that we can write as cos A, so that it is written as AC into cos A. As already stated, the formula for the potential equal to Q by 4 pi epsilon naught into 1 by R1 minus 1 by R2. We have also determined the cosine law, that is A square equal to B square plus C square minus 2BC cos A. But in our sum, in the place of A, we are having R1. Therefore, A is substituted as R1. Hence, we are getting A square as R1 square. Likewise, in the place of B, we are having R. So that the B is substituted as small r. Hence, we are getting B square as R square. In the place of C, we are having the distance D. So, I am also writing A as R1, B as R and C as D. Therefore, if we substitute C as D, we will get C square as D square. Therefore, we will get the equation as R1 square equal to R square plus D square minus 2RD cos theta. Because here the angle is given as theta. Now our duty is to find the 1 by R1. In this sum, the R1 is not given directly. On applying the cosine law, we have to find the R1. As per cosine law, in a standard triangle, if we know any two sides and the angle between them, we can find the third side. Here we have to find the side R1. Why should we find the distance R1 when the distance R and D are given? Because there will be potential due to the charge. This charge will provide the potential at point P. Center of the dipole will not provide the potential. The charge will provide the potential. So that we need the distance between the charge and the point P. That is, we need the distance R1. How we are going to find the R1? First of all, we are going to divide and multiply all terms of right side by R square. We are multiplying all terms by R square and dividing the first term by R square, so that we will get R square by R square. Then we are going to divide the second term D square by R square. After that, we are going to divide the third term minus 2 RD cos theta by R square. If we simplify R square by R square, we will get 1. If we divide 2 RD cos theta by R square, we will get 2D cos theta by R. The third term will be written as it is, that is D square by R square. As a next step, we are going to write R1 square as R square into 1 minus 2D cos theta by R. What happened to the term D square by R square? The D square by R square has been neglected. For what reason it is neglected? Since the distance D is much less than R, the D square by R square is neglected. Now the R1 square has become as R square into 1 minus 2D cos theta by R. Now we have got the equation for R1 square, but we need 1 by R1. So from this R1 square, we have to find the R1. After finding the R1, we are going to find the 1 by R1. How can we find the R1 from R1 square? If we square root all the terms contained in both sides, we will get R1. Square rooting both sides. Root of R1 square equal to R square into 1 minus 2D cos theta by R. If we inverse all the terms in the left side as well as in the right side, we will get 1 by R1 equal to 1 by R into 1 by 1 minus 2D cos theta by R, the whole power 1 by 2. If we bring this factor, that is 1 minus 2D cos theta by R, the whole power 1 by 2 to the numerator, the sign of the power will be changed. Hence, we are getting 1 by R1 as 1 by R into 1 minus 2d cos theta by R the whole power minus 1 by 2. Then using the binomial theorem, we get 1 by R1 as 1 by R into 1 plus d by R cos theta. In this case, we will neglect the higher power. In order to know the concept of binomial theorem, you can see my separate video, that is concept of binomial theorem. Now we have found 1 by R1. Our next step is to find 1 by R2